All right, let's kick off another deep dive. Today we're going someplace pretty wild in the world of physics, talking about information density. And no, before you tune out thinking this is all about computers, it's not.
No, not at all. This is about information on like a fundamental level, how it structures, how it interacts, how it might even play a role in gravity.
Gravity, seriously, like how much stuff weighs.
Yeah. The sources we're looking at today, they're actually challenging that basic idea, saying it's not just about mass.
Okay, I am intrigued. What kind of sources are we talking about here? Like, where is this radical idea coming from?
Some pretty dense scientific texts, actually. But they use some examples that we can all wrap our heads around, starting right here with planet Earth.
Okay, Earth, good old solid ground. What about it?
Well, think about the Earth's core.
Yeah.
Way denser than the crust or mantle, right? Smaller in volume, but packed with way more activity at the atomic level.
Yeah, crazy hot, tons of pressure, molten iron swirling around down there. But how does that connect to information?
Think of it this way. Every interaction, every little bit of energy exchanged, every change in state, that's all information flow. The more dynamic a system, the higher its information density.
So the Earth's core is like an information superhighway compared to the surface.
Exactly. It's like a bustling city versus a quiet suburb. Same amount of space, wildly different levels of stuff going on.
So are you saying that the Earth's core, even though it's smaller, could have a stronger gravitational pull because of this?
That's exactly what these texts are suggesting, that the structure and coherence of information is part of the gravity equation.
Whoa, okay. That kind of flips everything we think we know about gravity on its head.
Right. It's not just about mass, it's
Yeah.
about the information within that mass and how it's all, well, arranged.
So a pile of bricks has less gravity than a brick house, even if they weigh the same.
That's a simplification, but yeah, the
Yeah.
principle is there. And to really get this, we got to compare Earth to something totally different. Ready for it?
Hit me with it.
A black hole. Equal mass to Earth.
A black hole the size of Earth? That's terrifying. But wait, if they have the same mass, shouldn't their gravity be the same too?
By classic physics, yeah. But we know black holes, they don't play by those rules. Their gravity is off the charts compared to planets.
So what, black holes are like information vacuums, sucking it all in, making them even denser, even more gravity.
It's like they're not just dense, they're efficient with information. Think of a library where every book is perfectly in place versus one where it's all chaos. Same info, but one's way more powerful.
Okay, I can see that. A perfectly organized system versus a jumbled mess. But how does organization translate into more gravity?
That's the cutting edge of this research. One idea is that this information coherence, how well structured it is, actually warps spacetime. And warped spacetime, that's gravity according to Einstein.
Okay, well, hold up. Space-time, for anyone just tuning in, is that whole concept where space and time are linked, like a fabric that makes up the universe. And you're saying info can warp that fabric.
Exactly.
Yeah.
Black holes, they're the most coherent things we know of. So they warp spacetime the most. Nothing can escape their pull.
Okay, my brain's officially doing backflips. So it's not mass alone, it's how well organized that mass is at the information level.
And how it interacts, how it exchanges information.
Yeah.
It's a whole new layer of reality almost.
Totally. So we've got Earth's core, crazy dense, but not super coherent. Black holes, small, but incredibly coherent. What about other stuff out there? Stars, planets, do they play into this too?
Great question. Stars, they're massive, super hot, burning through tons of energy. And energy, as we've seen, is tied to information, but
But there's got to be a but here, right?
you're not as coherent as black holes. Like, yeah, lots of info flying around, but not with that perfect structure.
So a star is like a bonfire, and a black hole is like a laser beam. Both powerful, but one's way more focused.
Spot on. Stars, they let info escape as light and heat. Black holes, they lock it all down.
Makes sense. Okay, but what about planets? They're way smaller and cooler than stars. Does info density even matter for them?
That's where things get really interesting. The texts, they propose this thought experiment. Imagine Earth, same mass, but made entirely of magma. No solid rock, just swirling molten stuff.
Same mass. But if information structure matters, then maybe the state of matter does make a difference.
Exactly. Newtonian gravity would say no change. But this new idea, it suggests something else might be going on.
Okay, I am hooked. Tell me, what kind of difference are we talking? Would magma Earth have stronger gravity than regular Earth?
It might not be about stronger or weaker, but a different kind of gravity. All that molten stuff, it'd be exchanging information like crazy compared to solid rock.
So not about how much info, but how fast it's moving around, like a supercomputer versus a regular calculator.
Perfect analogy. And this brings up a huge question. Does the state of matter, solid, liquid, gas, does that change how information density affects gravity?
Whoa. This is getting deep, even for a deep dive. But before we go further down that rabbit hole, I think we need to back up a sec. We've been talking about how information affects gravity, but what about the other way around? Does gravity impact information at all?
Oh, absolutely. It's not just a one-way street.
Yeah.
Gravity doesn't just sit there and let information do its thing. It pushes back, shapes it.
Hold on. So gravity isn't just from information density, it also molds how that information is laid out.
Exactly. Think about it. Gravity pulls stuff together, makes things denser.
Yeah.
Right? When things get squeezed, those particles, they bump into each other more, exchange
Yeah.
energy more, which means...
More information is flowing.
Yeah.
So gravity is like a cosmic sculptor, shaping not just what things look like, but the information inside them too.
Beautifully put. And we see this everywhere. How stars form, how planets form, even galaxies, black holes. It's all this interplay of gravity and information.
That's wild. But okay, now I'm hitting a snag. If info likes to clump together, get denser, how does that work when the universe is expanding, spreading things out?
You've hit on one of the biggest mysteries in cosmology right there. It's this tension, this push and pull between wanting to get dense, but also the universe is getting bigger all the time.
Trying to picture this in my head just gives me a headache. How do those two forces even work together?
Well, maybe we need to rethink what information density really means. It's not just being packed in tight, it's also how complex the info is, how connected it is within a system.
So even though the universe is getting bigger, the stuff inside is getting more intricate.
It's one way to think about it. As the universe expands, there's more room for stuff to happen, more interactions, energy flowing around, new structures forming. That can boost complexity, even if things are spreading out overall.
So the universe isn't just getting bigger, it's getting smarter too.
A thought-provoking idea, to say the least. Information might be way more active in how the universe evolves than we ever realized.
Okay, let's bring this back down to, well, not Earth exactly, but different states of matter. You were saying before how that might matter for this whole infogravity link.
Right. We talked about magma Earth, how all that liquid hot stuff would have a different info vibe than solid rock. Now let's think about gases.
Gases! But they're like the least dense stuff out there. How do they fit into this?
That's where intuition can trip us up. See, gases might be light, but they often exchange info faster per volume than solids or liquids.
Wait, so like a puff of air has more going on info-wise than a rock. How's that even work?
Think about how gases are. Molecules bouncing all over, bumping into each other constantly, energy flying back and forth. It's a super dynamic info flow.
So even though they're spread out, those gas molecules are chatty little things.
Exactly. And that chattiness, even if there's not much mass, it could have subtle effects on how gases deal with gravity.
Mind blown yet again. But okay, if gases are so info-active, why don't they just collapse into black holes themselves? Shouldn't all that info want to be as dense as possible?
Here's where that coherence thing comes back in.
Yeah.
Black holes, remember, they're not just dense, they're organized. Gases, they're all over the place, chaotic.
So a black hole is a synchronized dance. Gas is a mosh pit. Both have lots of energy, but one's got a clear structure.
Perfect. And that lack of structure, that's what keeps gases from becoming black holes. Too much random info flying around to make that super strong space-time warp.
This is all so fascinating, but I gotta admit, I'm still fuzzy on how coherence does that warping. Like, what's the actual mechanism?
That pushing the limits of what we know for sure. But one way to think about it is maybe coherence creates a kind of resonance in space-time itself.
Resonance, like a tuning fork vibrating at just the right frequency.
Yeah, like that. Maybe information, when it's all lined up, it sends out these waves through space-time, and the more coherent, the stronger those waves, the more warp you get, the stronger gravity feels.
Okay, starting to click a bit. So gravity isn't just mass pulling on mass, it's info messing with space-time in ways we're just starting to grasp.
Exactly. And once you see it that way, it opens up all these crazy possibilities about how we might even use gravity differently someday.
Now that's a thought. But before we go full sci-fi, let's zoom back in on the basics. Black holes, stars, planets. What about the tiny stuff? Atoms, elements, do they play into this info density game?
Great point. In fact, the texts we're looking at, they talk about how the very first elements formed, and it's all tied to this. Remember hydrogen, the simplest one? Just one proton, one electron.
Yeah, the most basic building block, right?
And because it's so simple, Hydrogen is free to move around a lot. Those electrons jump between energy levels easily, and that means
Information is flowing fast, so tiny hydrogen, but actually a busy bee info-wise.
you got it. And in the early universe, super hot, super dense, that fast info flow was key to making the first elements. Hydrogen could adapt, combine, form heavier stuff.
It's like in a crazy environment, you got to be quick and adaptable to survive, right? And hydrogen was perfect for that.
Exactly. So this shows us info density isn't just about being big or complex. Sometimes it's about having the right structure for the situation.
So, in that early chaos, hydrogen's simplicity was its strength, allowed it to share info quickly, and boom, we get the elements that make up everything we see today.
Precisely. It's a perfect example of how information, even in its simplest form, was crucial to shaping the universe as we know it.
This is all so mind-blowing. We've gone from black holes to atoms, the whole spectrum. But before my head explodes, I gotta ask, where do we even go from here? Like, what does this mean for us, understanding the universe, our place in it, all that? Man, this whole information density thing, it's really got me thinking. Like, it's changed how I see the universe, you know?
It's a big shift, for sure. It's like we're not just looking at stuff out there, we're looking at the information that makes up that stuff and how it all interacts.
It's like before we saw the painting, now we see the brushstrokes, the colors blending, all the detail that makes it work.
And the more you look at it that way, the more amazing it gets, right?
Yeah.
There's so much depth we never even considered.
I'm humbled, for sure, but also a little overwhelmed, gotta be honest. So back to the big picture. Why does this matter? Like, beyond being cool, what's the point of knowing about info density?
That's the key question, isn't it? This isn't just theoretical physics in some ivory tower. Understanding this stuff, it could change everything from how we make energy to space travel, even how we think about consciousness itself.
Whoa, hold up. Real world stuff, not just like philosophical pondering.
Oh, yeah. Imagine, what if we could manipulate info density to make new kinds of energy sources? If information really is a fundamental force, could we tap into that?
That sounds like straight up sci-fi stuff.
Maybe today it does. But who knows what's possible down the line? The research we've talked about, it's just the beginning. We're only scratching the surface here.
It's like we've opened a door to a whole new understanding of how reality works. Information's not just along for the ride, it's shaping the ride itself.
And where do we fit in, right? Us, conscious beings who use information all the time. Maybe by understanding it better out there in the universe, we understand ourselves better too.
Now that's deep. Makes you wonder if consciousness, maybe it's part of this whole cosmic information dance somehow.
Worth thinking about, for sure. And hey, maybe that's a deep dive for another time. As we learn more, there's going to be even more to explore, more connections to make.
Well, folks, that's about all the brain bending we can handle for one episode. I hope you're walking away with more questions than answers, because that's what this is all about. Keep your minds open, keep digging, and who knows what amazing stuff you'll find.
And remember, information, it's powerful stuff. But it's also a responsibility, right? As we learn more about the universe, we got to use that knowledge wisely to make things better for everyone.
Couldn't have said it better myself. Thanks for joining us on this wild ride, and until next time, keep diving deep.